Okay, we'll start with a new topic, elimination reaction. So what is elimination reaction? So in an elimination reaction, two atoms or group of atoms that are removed from the substrate and which is leading to the formation of the pi bonds. Okay, you see here. So what's the elimination reaction? Two atoms or groups. Here, for suppose the two atoms or groups is one is W, the other one is X. Which means here you can take halogens like fluorine, chlorine, bromine, iodine. Okay, and you can take the W here. So when you remove this W, when you remove this X simultaneously, then it is generating the double bond here. Okay, so that's called as elimination reaction. Understood? So what is meaning of elimination reaction? It's one of the organic reaction where when you remove two atoms or groups here, that is W and X. So when you remove this from the substrate molecule, so that result in formation of the pi bond. So we know what is pi bond. So this one. Okay. Here as the pi electrons are involved. So we know if it is a single bond, it is sigma. If it is double bond, one is sigma, the other one is pi. So here there is a pi bond is formed. Okay. Between the two carbons. Understood? So remember, elimination reaction where you will be removing two atoms and you are forming an alkene here. So what is this? It is a alkene. Yes or no? So it is a unsaturated compound. So whatever the saturated compound is there, you are removing the group of atoms and you are making it as an alkene, which is an unsaturated compound. What is meaning of saturated? Saturated means having a single bond. Unsaturated means having double bonds or triple bonds. So whenever there is a double bond or triple bond, we call them as unsaturated. If it is only single bond, we call it as saturated. So remember, if it is single bond, it is saturated. Double or triple bond, we call it as unsaturated. So understood what is meaning of elimination reaction? So listen carefully. So you are taking a carbon. For suppose you take any two alkane group. So in that alkane group, you are removing an halogen, you are removing another atom, and which is resulting here the other in the sense it could be the hydrogen. Okay, and result in formation of an alkene. Okay, so that reaction is called as elimination reaction. So the word elimination, because we are eliminating two atoms or group of atoms. And after eliminating, it is forming the pi bond here. What is meaning of pi bond? If it is a double bond, one will be the sigma bond, the other one will be the pi bond. Okay. So remember, in the double bond, you will be seeing the pi electrons or pi bond. If it is all a single bonds, first suppose you see here, it is a sigma, it is sigma, sigma, sigma. Okay. So all are sigma when it is a single bonds. But when there is a double bond, one will be the sigma, the other will be the pi bond. So as you are removing the group, you are providing a place for the carbon to make a double bond. And you are making this atom as a unsaturated. Okay. So that reaction is called as elimination reaction. Is that clear for everyone? What is meaning of unsaturated? I mean, what is meaning of elimination reaction? Please say yes if you understood, or I'll repeat it again. Come on, guys. Have you understood?
Yes, sir.
Is there anyone is having doubt here? Dia, Sharon, Srikar, you understood this?
So the last part, could you repeat?
Are?
No, it's not your, I mean, it's
No, no,
lag.
no.
It's lagging. No, it's not. Because I can understand. It's lagging for me.
Okay. So just have a stable internet. So see here, you take an alkane. Okay. So in that alkane, which alkane you are taking? It's not an alkane, it's a alloalkane. Remember, we are taking alkyl halide here. Okay, so you take an alkyl halide. We know in an alkyl halide there is a halogen group contains and there are hydrogens are present. So this alkyl halide, you are removing the halogen group and you are removing the hydrogen. So that's why it is called as elimination reaction. Why? Because we are removing two atoms or group of atoms. So one is the halogen group, the other one is, it could be hydrogens. So W means, so withdrawing group. Okay. As you are removing this, it is making the pi bond between the carbon and carbon. So as you removed here, now the carbon is having only three bonds, but we know carbon should form four bonds. So carbon is making itself a bond with the other carbon. So that's how a single bond is turned out to be double bond. A alkyl halide is turned out to be alkene. A saturated compound is turned out to be unsaturated compound. So that reaction is called as elimination reaction. So in the elimination reaction, there will be pi bond will be formed as there is a pi electrons are involved. Okay. So
So P is for
understood.
double bond, right? And sigma is for single bond.
Yeah.
Okay. Yes,
Remember, whenever you see bonds like single or double or triple, so one will be sigma. Here this will be sigma, this will be pi. Here this will be sigma, pi, and there is a pi. Okay. So there is a two bonds. So one will be the sigma, the other will be the pi. Okay. So result in formation of the pi bond in the product molecule. So that reaction is called as elimination reaction. Understood, everyone? Is
yes,
there any doubts?
understood, sir.
Yeah. So beta elimination reaction. So in this, it is the type of elimination reaction in which the adjacent atoms are involved for formation of the pi bond. Okay. So remember, beta elimination reaction, it is also known as 1, 2 elimination, which is a specific type of elimination reaction. Okay. So what's happening here? So you take a carbon, which is having W, and the other one is having X. As you are removing WX, it is result in formation of the double bond between the carbon. Okay. Or you can write this as, okay. So here, the neighbor carbons are involved here. Okay. The adjacent atoms, whatever the adjacent carbons are there, we are removing the group from the adjacent carbon. So one you can take as 1, 2. So that's why it is called as 1, 2 elimination. So 1, 2 elimination. So why we are specifically mentioning 1, 2 is, first suppose let's take this kind of atom. Okay, I can remove one electron from here, I can remove one electron from here, or one atom from here. So in that condition, these are not the neighbor carbons. Okay, so 1, 2 we are specifically mentioned because we need to remove from the adjacent carbons or the neighbor carbons. Okay, first suppose if I take a 4 carbons, if I remove one group from here and other from here, then this will not become 1, 2 elimination. Even though we are eliminating, but it's not 1, 2 elimination. So 1, 2 elimination will only happen when it is a adjacent carbons. Is that clear? So two groups are removed from adjacent atom in this molecule. That you need to remember. So remember, when two groups are removed from adjacent atoms so that a new bond is formed between the adjacent carbons, that kind of elimination is called as 1, 2 elimination reaction. Okay. And remember, beta we are saying here because this is referring to the relative position of the atom. So one atom will be taking as alpha, the other will be taking as a beta. So alpha, beta. So the allosine group is attached to the alpha and beta is the other group will be attached here. Okay. So remember, it's my bad. So leaving group. So here the leaving group is, we call it as the allosine. So this allosine is mostly attached to the alpha carbon. And the hydrogen, you can also say it as a proton, which is removed, that will be attached to the beta carbon. Okay. So remember, here the alpha carbon is where the allosine is attached and beta carbon where hydrogen is attached. Okay. So you can call it as a hydrogen or you can also call this as a proton. Okay. And remember, this beta elimination reaction is mostly used for synthesis of the alkanes from alkyl halides or alcohol. Okay. So here, if it is alcohols, you will be taking OH here. If it is alkyl halides, it will be hydrogen. And mostly this will be the halosine group, fluorine, chlorine, bromine, iodine. Okay. Is that clear? So you can see here the beta carbon and the alpha carbon. Okay. So here on the beta carbon, the hydrogen is attached. and on the alpha carbon, the halogen group is attached. Okay. So halogen attached to alpha carbon, hydrogen is attached to beta carbon. Okay. And remember here, this alpha carbon, we call it as the leaving group. So this will be acting like a leaving group. Okay. So we know always the leaving group will take away the electrons. So this will be removing like a anion or cation. When it is taking away electrons with it, so will it act like anion or cation?
Anion.
Yeah. So mostly this will be the anion. And this one, whatever the hydrogen, it will be giving the electrons to the carbon and it will remove as a proton. So this will be the positive charge. So it will be cation. Is that clear? So leaving group, the halogen is attached to alpha carbon and it acts like a leaving group where it is leaving with the electrons. So it is an anion. And here the hydrogen is attached to the beta carbon and will be removed during the reaction like a cation. Okay. Or it will be removed like a proton. You can also remember like this. Okay. So the alpha carbon or the carbon where the halogen is attached. Okay. So, and remember here, the halogen is directly attached to the carbon chain. Okay. And the beta carbon is just adjacent to the alpha carbon. It will not be somewhere else. So that's why it is called as 1,2 reaction. It's not 1,3 or 1,4. They should be adjacent to each other. Is that clear? So next one, E2 reaction. So this E2 reaction is also called as the base-induced elimination reaction. Remember, we can also call this as the base-induced elimination reaction. Okay. So why we call this as a base-induced elimination reaction? Because most of this reaction mechanism is involved on the strong base. Okay. So here the base is a very, very important where it acts like the proton acceptor. Okay. So it acts like a proton acceptor. So what is proton acceptor here? So what is the proton acceptor? The carbon which is having the hydrogen here, after breaking the bond with the carbon and hydrogen, this hydrogen will be removed like a proton. So who will accept this proton? This will be accepted by the base. Actually, who will break this bond? So when a strong base comes near to this beta carbon, that will induce the bond breakers between the carbon and hydrogen. So that's how this hydrogen will start leaving this carbon and it will try to attach to the strong base which is present here. So that's why this is very, very important. So when the base comes close to, first suppose base is somewhere here. So the atom, the molecule will remain like this. But when the base comes close to this beta carbon, the strong base, then it will break the bond between the carbon and hydrogen. So that will make the reaction to continue. So the base is inducing the elimination reaction here. So that's why this reaction is called as the base induced elimination reaction. Is that clear? And where does this base is specifically targeting? It is targeting on the carbon where it is attached with the hydrogen. So this is beta carbon. This is alpha carbon. Okay. So it's mainly targets on this carbon where the hydrogen is attached. So remember that one as well. Okay. So it targets on beta carbon. Okay. Of the alkyl halide. So when this is targeting on the beta carbon, when it is trying to break the bond between the carbon and hydrogen, it is trying to pull this proton. Okay. So this base, the strong base, will try to pull the hydrogen to it. Okay. So that's why the hydrogen will leave the carbon and it will go near to this base. Okay. So at the same time, simultaneously, whatever the halogen is there, it will try to break the bond with the other carbon. See, this halogen will attach to this carbon normally. But when here the proton is leaving, at the same time, this halogen is also trying to leave. So there is a bond breakers will happen at the alpha carbon as well. It is breaking the bond with the halide here, halogen here. So From this, I can tell that so there is a strong base is required for this reaction to continue. Okay. So strong base is required. Why? To pull the hydrogen, to break the carbon and hydrogen bond, to pull this hydrogen. So that will initiate or that will induce the elimination reaction. So that's why we need a strong base here. Okay. So mostly the strong bases are alkoxides. You can take like alkoxides, which are RO minus, or you can also take ethoxides, which is C2H5O minus. See, it is ethanol. If you remove the hydrogen proton here, that will turn out to be ethoxide. Okay. And you can also take as hydroxides. So which is OH minus. So this OH minus, when it comes close to the beta carbon, so this will try to break the bond with the carbon and halogen. So this will go and attach and they will turn out to be water molecule. The same with ethoxide, it will turn out to be ethanol. The same with alkoxide, it will turn out to be alcohol. Is that clear? And one
Yes.
more thing you need to remember here is, so if you see here, the hydrogen is opposite to the halogen. Okay. So if you see the stereochemistry here, the base approaches the molecule from the opposite direction where the leaving group is leaving. So for suppose the leaving group is leaving from this downside. So leaving group leaving from downside. Then here the base is attacking from the top. Okay. So base is attacking from the top. So that you need to remember here. Okay. So where the leaving group is leaving from the downside, from the opposite direction, the base is attacking here. Okay. The base is attacking the proton and it is trying to pull this proton towards it. So there will be bond breakers between the carbon and proton. So here the proton is removing and here the halogen is removing. So that's why it is a E2 reaction. Is that clear? Any doubts so far here?
No.
Okay. So remember, this is a dehydrohallucination, which will be taking place by two steps. Okay. So one, elimination of hydrogen and halogen. From an alkyl halide to form an alkene. And two, N takes place by E2 mechanism. I'll tell you what is this. So let's see E2 reaction with an example. C2H5O minus. So what is here? E2H5O minus. So why do we need E2H5O minus here? How does the C2H5O minus helpful here?
Sure, it's a base.
Yeah, it will be a strong base. Okay, so which will pull the hydrogen from here. So let me write in the form of structure. So C, hydrogen, C, bromine, CS3. So now I'll bring the strong base here, which is C2H5O minus. We discussed here what are the strong bases, ethoxide, hydroxide, or alkoxides. So I am using here ethoxide. So when this is approaching here, it will try to break this hydrogen and pull this hydrogen towards it and convert into C2H5OH. Understood? So it will try to pull this hydrogen and make it convert into C2H5OH. So at the same time, what happened? There is a bond breakage will happen with the bromine. So here the bromine is acting like a leaving group. Okay. And what is a carbon? This one? What could be this carbon is called as?
Viral
Beta or alpha?
alpha.
Yeah, this will be the beta carbon. Remember here, see, I'm removing hydrogen from here and bromine from the alpha carbon. Okay. So that will result in formation of CS2 double bond CH bond CS3 plus what we got here C2H5OH. And what else we got here? The Br is left over, so which acts like a bromide ion. Understood? So tell me what are the names here? So what is this molecule name called as? So second, it is having the bromine and it's a 3 carbon. So we call it as, come on guys, name it. 2-bromo
Methyl.
Propane.
propane. Why methyl?
Okay, okay.
Second bromine on the propane. So 2-bromo propane. And what is this called? Ethoxide
Ethoxide.
ion. And what is this called? There's a double bond in 3 carbons. So we call this as prop, one in, or you can simply write it as propene. And what is this? C2H5OH, alcohol with a 2 carbon.
Ethanol.
Ethanol.
Ethanol, sorry.
And this is bromide ion. Come on, guys, be strong in the IUPAC naming. Okay, so this is how the E2 reaction will happen. And remember, in order to have this reaction, we need a strong reagents. So what are the strong reagents? One is hot alcoholic solution we use. Of KOH. I'll tell you what is this, or ETO or ETOH. Okay. So what is ETO and ETOH? The other one, the other reagent that we need is NaNH2. So these are the two which are very, very helpful. So we need hot alcoholic solution of potassium hydroxide or ETO or ETOH. Come on, what is ETO? You never heard this? What is meaning of ETO? It is ethoxide ion, or ETOH, we call it as ethanol. Okay, and KOH is a potassium hydroxide. And what is meaning of NaNH2? Strong amide. Okay, so it could be as NaNH2, it's a sodium amide. Okay, so remember what are these? These are all strong bases which are really necessary for elimination reaction. Okay, so alkoxide ions for elimination reaction. So let's see how does the actual mechanism will happen. So remember, it actually happens by 3 ways. Okay, so first one is base approach, and then transition state, and finally the bond formation or breaking. Okay, first suppose let me take the example. So concentrate carefully. The mechanism is very, very important. So initially I have like this. The what is this? What is this group called as? Is that alkane, alkene, alcohol? What is this? The carbon with an halogen. What we called?
Fluorine.
Hello.
Alkane.
Haloalkane or alkyl halide. Okay. So this alkyl halide, what happens when a base comes close to this? So let's take a base that is coming close to this. And whatever the hydrogen that is present here, so this strong base will attack on this hydrogen. Yes or no? Simultaneously, at that condition, what else is happening? When the base is attacking the hydrogen present on the beta carbon, simultaneously, there is a bond breakage will happen between the carbon and halogen. Is that clear? So this one we call it as the base approach. Is that clear? So when the base is approaching, it is inducing the reaction to happen by pulling the hydrogen here. So when it is pulling the hydrogen, whatever the halogen is present here, that halogen is also trying to break the bond with the carbon. Understood? So that is the first process. So once that is over, what happens then? It will result in formation of a transition state. So what is the transition state is? There is a carbon that is breaking the bond with the halogen, and that is also breaking the bond with the hydrogen because the base is pulling this hydrogen. So as the bonds are breaking here, so the carbon is also needs to form the bond with the other carbon. So there is a double bond formation will happen here. So as it taking the electrons, so this will be slightly negative charge, and here the hydrogen will be positive charge. So it is leaving like a proton, and whatever the base that is attacking here, the base is containing the negative charge. Okay, the one which is making the bond with the hydrogen. So here the hydrogen is making the bond with this base, or you can write like this. This condition or this stage, we call it as the transition stage. Understood? What happens? Or you can say it has a transition state or stage. So once that is over, now the bond break will completely happen between the carbon and hydrogen. So it will finally leave. And whatever the double bond it's making here, so that double bond is formed. And whatever the halogen is left here, it will leave. So it converted into an alkane. And this X minus will be removed like a bromide or whatever the ion we take here. And whatever the bond with the base, it will be formed. So BH. So finally, the bond formation and breakage. Understood? So remember, this will happen in 3 steps. One is base approach. So the strong base will come and approach. So here the strong base will target on which carbon? Alpha or beta carbon? Nitya, you tell me what happens here? The strong base will approach to which carbon? Alpha carbon or beta carbon?
Beta carbon.
It will attack on hydrogen on beta carbon. Okay. So next one, the second step is transition state. So what happens in this transition state? What are the things we are seeing here in the transition state? So one is the base is making the bond with the hydrogen, and hydrogen is breaking the bond with the carbon. Carbon is making double bond with the carbon. Carbon is also breaking the bond with the halogen. So these are the four things we saw in the transition state. Okay. So first one is base pulls the protons, pulls the proton, which is nothing but the H plus. Second is the carbon is making the double bond with the carbon, or you can, so carbon making double bond with other carbon. Third thing is, so whatever the leaving group here, what is the leaving group here? The halogen. So carbon and halogen bond starts breaking simultaneously. See, all these things will happen simultaneously. When the base is pulling the proton, the carbon and halogen bonds also will start breaking. Okay, so start breaking simultaneously. So as all these things are happening, we can see there is a partial negative charge will develop on both the base and the leaving group. Okay, so that's the another thing. So partial negative charge will build on leaving group and base. So finally, that will end up with making the bond formation. So bond formation. So first all the bonds will break and then bond formation will happen. So bond breaking and bond formation. So this is how the elimination reaction will happen. Is that clear? E2. What is meaning of 1, 2 elimination reaction? Any doubts so far?
No, sir.
Mandara, is it clear for you?
Yes, sir, it is.
So this is the E2 reaction and E2 mechanism. What about Sharon, Dia, Srikar?
Yes, sir.
Yes, okay.
Okay. So how do you tell? Let's see what are the characteristics of the E2 reaction. So first one, we can simply say it is a single step bimolecular reaction. Yes or no? So the E2 reaction occurs in one step. Yes or no? So there's a one transition state and finally it formed into a product. So it is a one-step method. So it's a single step bimolecular reaction as two molecules were involved here. Okay. So both the species are participating in the rate determining step here as well. So remember here, so whatever the base that acting and halogen that's leaving, so both are participating. That's why it is called as bimolecular reaction because it depends on both the two. So that's why it is a rate determining step. Both species were participating. So it's a rate determining. So both species participation in the rate determining step. If it is only one species that is participated, then we call it as unimolecular reaction. As both species participate in rate determining step, we call it as bimolecular reaction. Okay, so what are the both species here? One is the alkyl halide. So whatever the year you are taking, that's alkyl halide. The other one is whatever the base you are taking. So those are the two species here. Okay, so remember that one is alkyl halide. The other one is whatever the base you are taking. So their both concentration will determine the the reaction rate. So that's why both species participate in rate determining step. So we call this a single step bimolecular reaction. Okay. And this reaction is called as the second order reaction because it depends on the concentration of two reactants. Okay. So remember this, it is the second order reaction because the concentration of two reactants it determines. So concentration of two reactants. So that's why it is called a second order reaction. Third thing, rate is directly proportional to the concentration of the alkyl halide and the concentration of the base. Okay, so the rate or the reaction rate is proportional to both the concentration of the alkyl halide and the base. So this will confirm the bimolecular nature of the reaction as well as second order reaction. So rearrangement is not possible. So we saw in substitution reaction there's inversion and all. So here no rearrangement is happening here. Okay. So unlike some other reactions, like we saw, right? So in order to form the tertiary, they are shuffling the methyl group, hydryl group. So that rearrangement is not possible here. Okay, so they will not undergo any rearrangement here during the elimination process. So the other one is the orientation of the proton and the leaving group should be anti. Okay, so we saw so the orientation of the proton and the leaving group should be anti. So we saw here. So the leaving group is on the other direction and the base attacking is on the other direction. So the orientation of proton and leaving group should be anti. Next one, here BH is eliminated by the base and it is known as beta elimination. Yes or no? So which one is inducing the elimination reaction? By the alpha carbon or beta carbon? On the beta carbon where hydrogen is present. So the base is inducing, pulling the hydrogen, and this reaction is continuing. So the main molecule that is inducing the elimination reaction is base, which is present, which is inducing on the beta carbon. So that's why it is called as beta elimination. Is that clear? And finally, if two or more eliminated products are possible, the product will mostly highly substituted double bond with predominant Seger's rule. Okay, so what is this Seger's rule is when multiple elimination products are formed, like when you get more than one product, the more substituted alkene is favored. That we'll see anyways. I'll tell you in detail. So from this, I can tell you there could be a chance for formation of the major and minor products. As there are multiple products can be formed, so there is a there's a major and minor products could form. So dehydroallogenation. So let me write this. Okay, I told you Sage's rule. Okay, there could be multiple chances. So now tell me which could act like alpha carbon and beta carbon here. What are the chances? So the base can attack on which positions? See, this is my this is my alpha carbon because halogen is attached. So now which one will be the beta carbon? Whether this could be or this could be or this could be. One thing is this cannot be possible because both are same. Okay. Second one. So you see this one. The base when it comes, it could attack on this hydrogen or this could attack on this hydrogen. Yes or no? So when it attacks on this hydrogen, what happened? So this hydrogen will break the bond with this carbon and this one will break the bond. So this bond will try to make here. So double bond will be made here. Okay. So when this is broken, double bond will be formed here. When it is broken, the double bond could form here. Okay. So based on that, there could be a chance for two products formation. So one is CS3, CH double bond, C, CS3. The second one is CS3, CH2, C double bond, CS2, CS3. So there is a chance for formation of A or B product. Okay. So if you see the A product could be formed by the Sejef's rule. So that's why this is called as the Sejef product. And here the B could be formed by the Hoffman's product. You don't need to remember this Sejef and Hoffman if it is not given in the NCRT. But yeah, it is mentioned. NCRT actually it's mentioned. So just know this. There could be CHF product and Hoffman's product. Okay. So once, so tell me what is the difference here? So what is this carbon and what is this carbon? If you see this carbon, what is this carbon? Primary or secondary? This is primary and this is tertiary carbon. And if you see this one, this is tertiary and this is secondary carbon. Okay. I'll tell you the reaction order. Actually, the tertiary is greater than the secondary is greater than the primary. Okay. So remember this. So here we have a tertiary secondary carbon and here we have a tertiary and primary carbon. So that will define Auman's product and CHF product. So write down this one. Draw the structure. So if you see the secondary carbon and tertiary carbon, these are mostly substituted. Okay. So CHF product says this way. So write down the what is the definition of this CHF rule and so first one is CHF rule. So what this CHF rule says is in an elimination reaction, the more substituted alkane will be the major product that's because of its stability. If it is more substituted, it will be more stable. And the next one is Hoffman's product or Hoffman's rule. So what does this Hoffman's rule says is in an eliminated reaction, Okay, see here now. What is this Sejev rule is saying? So in an elimination reaction, the more substituted alkene will be the more major product. So if you see here, this is the Sejev. So here, this carbon you take, it is substituted with two other carbons and it is attached with some other. So it's a tertiary. Tertiary is mostly substituted. And if you see the secondary, it is also having one group that is attached. So it is more possible according to Sejev product, because he says that the more the substituted, the major it will be. So, and it gives the stability if it is attached with more compounds. But what happens if our what how this reaction is induced because of the base that is present? If the base is itself very bulky, it cannot go here, and it is very easy for to attack on the terminal compared to the central. So in an elimination reaction, the less substituted alkene sometimes formed as a major product because the bulky base is used. Eh, and it causes the steric entrance to difficult to abstract. So going and obtaining the hydrogen here is very difficult as it is surrounded with the major. Okay, so it is feasible as it is present at the hand. So that's why Hoffman's products, sometimes this will be formed as the major product when you are using the bulky base. You understood? So what is meaning of this Sejaf product and Hoffman's product? It is very important. The MCQs can come on this. Is this clear for everyone? Come on, guys, please answer something. Understood or not understood?
Yes.
So from now onwards, just answer me if you understood means yes or no. Don't keep yourself muted.
So can you repeat it once more?
See, what this Sejaf rule is saying is, so when there is a more substituted alkene, that will be formed as a major product. So here more substituted means when it is formed with more number of atoms, bonded with more number of atoms. For suppose you see the tertiary carbon and the secondary carbon here. So they are surrounded with more number of atoms. For suppose this one and this one, secondary. Tertiary is this one, and this one. So this carbon is surrounded with more atoms, this carbon is surrounded with more atoms. So according to Sejaf product, the double bond will form between the two. But what Hoffman product says is, Hoffman rule says is, so when you are taking the base, bulky base, so the base which is surrounded, which is having multiple carbons on it. So this, what happens? It will produce the hindrance effect. We studied what is meaning of hindrance. So going and abstracting the hydrogen from the second carbon, it is very difficult for the bulky base. The bulky base can easily obtain the hydrogen from this carbon compared to this carbon, because going this bulky group and abstract this hydrogen is very difficult. But here it can easily abstract as it is present at the end, as it is present at the terminal. So that's what Hoffman product says. Hoffman rule says. So this is only in conditional time. Okay. So that's why in an elimination reaction, less substituted alkene sometimes formed as major product under specific conditions. What are those? Like when you have a bulky base. That's due to the steric entrance. Is that clear?
Yes, sir.
Yes, sir.
Yes.
Okay, fine. So characteristics of E2 reaction. So you remember reactivity towards E2. For suppose if you take the halogens, so alkyl halides Ri is greater compared to RBr, is greater compared to RCl, is greater compared to RF. So remember this. So fluorine, chlorine, bromine, iodine. So actually it increases when it goes down. Okay. And rate of E2 reaction, this will be like this. So tertiary alkyl halide is greater than secondary, is greater than primary. So remember these two. Okay. So next one, factors affecting E2 reaction. So one is
So
the
can you
nature of
repeat
alkyl.
it? Yes, sir.
Done.
I just missed one last one, sir.
So next one, So factors affecting E2 reaction. One is nature of alkyl halide we take. So nature of alkyl halides. What could be the nature of alkyl halides means? You can consider the examples like tertiary is greater than secondary is greater than primary. So that is one which is influencing. So second one, nature of base. So how it should be our base is strong or weak base?
Strong.
It is a strong base. Next one, nature of the solvent. And finally, leaving group ability. So we saw in the previous condition, leaving group ability. So tell me, what is the leaving group ability? Iodine is more ability or chlorine is more? Okay. And remember, so which one is majorly playing important role is first, whatever the first one is the stability. Okay. So remember the main thing is the stability. So stability of alkenes will govern the rate of reaction. If for suppose the final product is not stable, then it will not produce the reaction rate. It will decrease the reaction. So stability of alkenes governs the rate of reaction. Remember this. Okay. So we saw what is the nature of alkyl halide. What is the order? So tertiary is greater than secondary is greater than primary. Just remember that. So all these are alkyl halides. So rate of E2 reaction depends on the concentration of base as well. Okay. So depends on concentration of base. So a stronger the base is more favorable for E2 reaction. And choice of solvent depends. Okay. So we saw here previously. Yeah, you see here. So what is the solvent? Hot alcoholic solution of potassium hydroxide or ETO or ETOH. So here it depends on the choice of solvent. Okay. So or the reagent we are using. So for suppose ETO minus is taken compared to ETOH. Okay. Is taken. Next one, weaker bases are good leaving groups. So Ri is greater, RBr, wait, yeah. So relative reactivity of alkyl halides as well. You remember this? So finally, so tell me what are the E2 reactions? So one is, come on, tell me what is a E2 reaction? It's a bimolecular. Next one, it follows which rule? I told you two rules, but majorly it follows which rule without any conditions? Sejef rules.
Stages.
Okay, follows. Next one, there is a, we saw the transition state as well. So remember that one as well. And remember the E2 reaction will be more well happen when it is a high temperature. And it's a single step reaction. And it's a requirement of the strong base. And if you see the alkyl halides, tertiary is greater than secondary is greater than primary. And whatever the solvent we are using, it is a fixed solvent. Okay. So we can use the ETOH or we can use the other solvents. So tell me, so which among the following is most reactive towards alcoholic KOH? So here the alcoholic KOH is a base. So which one would be the option? So which one is surrounded with more number of, according to Sejaf rule? Which one is having more substituents? If you see here, this is not having any substituents. It's mostly all are hydrogens. Even the same way here. If you see here, this is okay. Only one substituent is present. But if you see here, this carbon and this carbon, it is having one substituent. On the right side, it is having one substituent. Okay. For so this one and this one. So here, this is beta alpha. This is beta alpha. This is beta alpha. And this one is beta alpha. So which one could be the option? Which one is having more substituents?
Option C.
Option C.
Yeah. Okay. Remember, so this one will be the better option. So what could be the major and minor products in this? So what are the chances first? If you see here, this is the alpha carbon and my beta carbon could be, which one I can take? Either I can take this beta carbon or I can take this as a beta carbon. Yes or no?
Yes, sir.
So which one will be major? This one or this one? This one is A, B. So tell me, A will be the major or B will be the major?
B.
Yeah, B will be the major. So the substituents will be formed like this. Okay. So it will be having CS3 and it will make double bond here between the alpha and beta. Or it could make like this. So this will be my major product and this will be my minor product. So is this clear? Any doubts?
No, sir.
No, sir.